Greetings, ladies and gentlemen. Thank you for joining me. Welcome to TJ's Maths and Further Maths Adventures. If you're new here, please thank you for joining me. The returning viewers, I really appreciate you for your support. In today's presentation, we continue with our solutions to Senior School Certificate Examination NECO 2024. This is paper 2 part 2 and this is mathematics. With us here is question 9a and 9b. In my previous video, I have solved question 1 to 8. This is question 9a and 9b. Question 9a reads, the ninth term of an arithmetic progression is 61, while the 21st term is 145. We are asked to find the sum of the first 48 terms. Question number 9b, we are asked to evaluate. We are asked to evaluate the integral of 0 to 2 of bracket open 3 over 2 of x squared plus 5 close the bracket with respect to x. First thing to do is to identify this question 9a is from which topic. 9a, of course, is from sequences and series. Two types of sequence. We have arithmetic progression and geometric progression. With us here on the board is arithmetic progression. Of course, question 9b is from integration. Two types of integration. We have definite integral and indefinite integral. With us here is definite integral. Definite integral means that is why we have limit as 0 to 2, the lower limit and the upper limit. Let's look at how we can solve this together. First thing to do, let's write down the solution here. We'll write down the solution to A now. We are talking about arithmetic progression. Nth term of GP or AP rather, A for arithmetic, P for progression is given as Tn, which is equals to A plus n minus 1 times D. Given that A is the first term, n is the number of terms, D is the common difference. When we are talking about ninth term, it means n is 9. So let's substitute 9 as n into this one. So it means T9 will be equals to A plus 9 minus 1 times D. So T9 now will be equals to A plus 9 minus 1 is 8 times D, that's 8D. From the question we are told that the ninth term is 61. That will be A plus 8D will be equals to 61. This will form equation 1. Okay? Let's move to the next statement. We are told that while the 21st term is 145. What does that mean? It means we substitute n as 21 into this nth term. Anywhere we see n, we put 21. So T21 now will be equals to A plus 21 minus 1 times the common difference D. So A plus 21 minus 1 is 20 times D, that's 20D will be equals to 145. This is equation 2. So we have two beautiful equations here with us on the board, equation 1 and equation 2. So for us to find the sum of the first 48 terms, we need to find the first term and the common difference D. So let's move here to do that. Okay? So let's move here to solve the two equations. Okay? Our equation 1 is A plus 8D equal 61. Then our equation 2 is A plus 20D equal 145. So at this point, we can use one of the methods because this is simultaneous. We have two unknown here. This we can apply any of the method of simultaneous equation, either elimination method or substitution method. Let's eliminate A. Let's apply elimination method. What does that mean? So we have to subtract equation 2 from equation 1. So let's do that here. We can, A will go 8 minus 20d, that will be minus 12d. This will be equals to 61 minus 149. Of course, that will be minus 84. Let's check that. 61 minus 145, that will be minus 84. Okay, so we can easily find D now. So let's move here to find the common difference. Let's click here so that we can get the common difference. To find the common difference now, we have minus 12d equals to minus 84. So we can divide through by the coefficient of d, which is minus 12. Divide through by minus 12. D now will be, minus will divide minus, which is 1. 84 divided by 12, we have 7. So the common difference is 7. So if the common difference is 7, what will be our first term? So to do that, we can say put D equals to 7 into one of the equation. Let's say equation 1. Equation 1 is A plus 8D equals 61. So it means anywhere we see D here, we put 7. So this will be A plus 8 into 7 equals 61. So A now will be A plus 8 times 7 is 56 equals to 61. So A now will be 61 minus 56. So A now will be 61 minus 56, that will be 5. So the first term is 5. The common difference is 7. So we can easily find the sum of the first 48 terms. Sum of the first 48 terms means n is 48. That's what it means. So let's move here. Sum of arithmetic progression, when the last term is not given, is given as sum now will be equals to n divided by 2 square bracket 2a plus n minus 1 times the common difference. Then we close the bracket. This is the formula we are to use. This is the sum formula. Okay? So to do that, let me clear here. We need n, and from the question, the sum of the first 48 times means n is 48, comma a is 5, comma d, the common difference is 7. So we have all the information. So it means we can substitute this information back into this formula. Sum of the first 48 times now will be n. In place of n, we put 48 divided by 2 into 2 times 5 plus, in place of n, we put 48 minus 1. The d is 7. We close the brackets. Okay? So let's move here to resolve that quickly. Okay? From here, sum of the first 48 terms now will be equals to, we can reduce this 2 here 1, 2 here 2, 2 here 4. That will be 24, bracket open, 5 times 2, that's 10, plus 48 minus 1, that's 47 times 7. 47, let's use our calculator, times 7, that will be 329. Sum of the first 48 times now will be equals to, bracket first, let's add what is in the bracket, 329 plus 10, 329 plus 10, that's, it will be 24 into 339. Then sum of the first 28 times now will be, we multiply that by 24, that will be 8,136. So this will be the sum. This will be the sum of the first 48 terms. So this is the solution to A. Let's quickly move to B. Let's click here to solve B. Very interesting. B is a definite integral. The first thing for us to do is to integrate this normal way. using the general formula of integration, meaning we can integrate this separate. Okay, let's write down the solution now to b. As I said, we integrate before we take the limit. We have the lower limit and the upper limit here. Okay, so let's integrate this separate. I have 3 is dividing 2. This x square here, we increase this power by 1 and we use the power to divide. That's 2 plus 1 plus the integral of this constant 5 here with respect to x will be 5x. Then we write down the limit 0 to 2. Okay, so here I can separate this. That's 3 divided by 2 times x power 2 plus 1 is 3 divided by 3 plus 5x. Then we write down our limit 0 to 2. Very important. Okay, so here, let's clean here. Uh, Here we can reduce this. 3 here, 1, 3 here, 1. Okay, so we're left with x cubed divided by 2 plus 5x, then we have our limit 0 to 2. So at this point, we can take the limit. That's we pick the upper limit, substitute into this, minus, we pick the lower limit, we substitute into this. Upper limit 2, that will be 2, all in power 3 divided by 2 plus 5 into 2. This is now the upper limit minus the lower limit. That will be 0 all cubed divided by 2 plus 5 into 0. You realize that everything here will be 0. So we're left with only this. Okay? So let's move to the other side to see how we can resolve this. Okay? Here we have 2 cubed is 8. That will be 8 divided by 2 plus 5 times 2 is 10. That will be 10 upon 1 because any whole number has a denominator of 1. So we can easily find the LCM of 2 and 1 will be 2. 2 into 2 is 1 times 8, 8 plus 1 into 2 is 2 times 10, that's 20. This will now be 28 divided by 2. 2 here, 1, 2 here, 1, 2 here, 4. That will be 14. So the answer to this B is 14. That is why it is definite integral. But if it is indefinite integral, we put arbitrary constant. We integrate and put the arbitrary constant. But if it is definite integral, definitely we have a number. It could be a fraction, it could be a whole number like what we have on the board here. We have 14. So this is the solution to this question. Thank you for watching. Please do share this to your learned colleagues. And don't forget to subscribe to my YouTube channel for more interesting videos. In my next video, God's willing, I will solve question 10, very interesting, and 11, 13 in that order. Thank you for watching.